If you just glance at Apple's history from the outside, it probably looks like a pretty standard timeline of product launches and flashy keynotes. Actually, scratch that. Beneath the surface, Apple's hardware strategy is much more like a highly calculated, repeating business thriller. I'm talking about a story full of secret labs, brilliant backup plans, and incredibly ruthless pivots. Today, we're unpacking one of the most significant and honestly brutal shifts in the entire history of modern computing.
Okay, let's dive right into this. Why did Apple really abandon a 15-year partnership with Intel, seemingly overnight? It is incredibly easy to just assume this was a sudden reaction to Intel stumbling, a quick fix to a temporary problem. But the switch to Apple Silicon, there was no way that was an overnight whim. As we'll see, it was actually the culmination of a highly classified, decade-long secret plan.
The answer to that question really boils down to one simple core philosophy. Apple doesn't stay loyal to partners, they stay loyal to their product vision. They are fundamentally obsessed with extreme efficiency, having absolute 100% control over their ecosystem, and pushing the literal physical boundaries of computing hardware. They don't do partnerships out of sentimentality. If a partner, whether that's IBM, Motorola, or Intel, fails to deliver the exact specs Apple needs to make their hardware vision a reality, they won't hesitate for a second to leave them in the dust. To really wrap our heads around the massive industry shockwave of 2020, we actually have to flip the calendar backward. Section 1, a history of breakups. If you look back, Apple has this wild track record of always having an escape route locked and loaded. Back in 1994, they allied with Motorola and IBM to create PowerPC chips. But by 2001, the exact same year they launched Mac OS X, Apple's engineers were secretly compiling a parallel version of that operating system to run on Intel chips. Intel was practically the enemy at the time. It was just a brilliant insurance policy. When IBM eventually failed them, Apple executed the Intel switch in 2005. So fast forward to 2020 and that Apple Silicon launch, it's really just the latest chapter in a long history of having a massive backup plan ready to go. It's crazy how history completely repeats itself here. Back in 2005, Steve Jobs promised a 3 GHz G5 chip, but IBM's processor ran so unbelievably hot that it literally required a liquid water cooling system. Obviously, that's impossible to fit inside a laptop. Flash forward to 2020, and the root problem with Intel was exactly the same. Heat. Intel's chips were running so hot that MacBooks sounded like jet engines taking off, and they were suffering from severe thermal throttling. Apple dumped both of those companies for the exact same reason. Hot, power-hungry chips were completely ruining their vision for sleek, quiet laptops. Which brings us right into the 2010s. Section 2, Intel hits a wall. And we start to see this rock-solid partnership begin to crack. For decades, Intel's absolute dominance of the market relied on this super predictable manufacturing rhythm they called tick-tock. It was basically clockwork. Shrink the manufacturing process one year, improve the architecture the next. But in the 2010s, that rhythm totally broke down. Intel's transition from 14 nanometer to 10 nanometer manufacturing slipped, and then it slipped again. This massive delay meant Intel was stuck trying to refine old processes, which effectively slammed the brakes on the year-over-year innovation that a company like Apple absolutely demands. So, what did this actually mean for us, the users? Well, it wasn't pretty. Like I mentioned, MacBooks were sounding like jet engines even under basic workloads. Because the chips were getting dangerously hot, their sustained performance would plummet just to protect the machine from melting itself. Plus, you had this severe battery drain. The contrast was just glaring. Apple engineers were designing these world-class, ultra-thin machines only to watch them completely buckle around Intel's thermal limits. Their entire hardware vision was practically being held hostage. But Apple wasn't just sitting around waiting for Intel to figure it out. Section 3, the secret mobile advantage. While the traditional PC world was completely reliant on Intel's incredibly complex architecture, Apple was quietly mastering ARM. That stands for Reduced Instruction Set Computing. Instead of relying on raw, power-hungry clock speeds, it uses simpler instructions and draws significantly less power. It was built from the ground up for extreme efficiency per watt. And because of that design, ARM scales perfectly. It works in a tiny embedded device, scales up to an iPhone, an iPad, and eventually, a full-blown desktop computer. Then came the massive aha moment, somewhere between 2010 and 2018. Apple had been iterating relentlessly, going from the A4 chip all the way to the A12. Suddenly, the tiny, completely fanless chips inside an iPhone XS were matching, and in some cases actually beating, Intel's laptop CPUs in single-core performance. Can you imagine that meeting? Apple's engineers realized the chips sitting in their pockets were outperforming the hot, power-hungry processors inside their actual workstations. That exact realization sparked Project Calamada. This was a highly classified internal initiative launched back in 2014. That is 6 whole years before they ever broke up with Intel. The goal wasn't just to make a slightly faster phone chip, it was to build a legitimate desktop-class processor alongside TSMC, the world's leading semiconductor foundry, using cutting-edge 5-nanometer manufacturing. It was basically a massive tech espionage operation, happening right under Intel's nose. Flash forward to 2020, and all that secret planning gets unleashed. Section 4, the M1 ship shockwave. Normally, traditional PCs are kind of like a giant puzzle. You have separate chips for the CPU, the graphics, the memory, and moving data between them creates massive traffic jams. The M1 completely rewrote the rules. It is a system on a chip, or SoC, meaning it unifies all of those components right into one single piece of silicon. Because everything is drawing from the exact same pool of memory, there are virtually 0 bottlenecks. That's why it's so incredibly fast, and crucially, why it runs so cold. Now, changing a computer's fundamental architecture usually spells total disaster for software developers. But remember that 2005 breakup? Just like Apple deployed Rosetta 1 to flawlessly run old PowerPC apps on Intel chips, they deployed Rosetta 2 for the M1. It translated legacy Intel software to run natively on ARM in the background. It made the entire transition practically invisible for everyday users, instantly removing the single biggest barrier to adoption. 210 days. To put that into perspective, when Apple announced the massive switch to Intel back in 2005, they promised a 2-year transition, but they totally finished it in just 210 days. That same staggering, ruthless velocity is exactly what they brought to the M1 rollout. When Apple commits to a new product vision, they don't just walk, they completely sprint. And the results? I mean, they were so mind-blowing that professional reviewers initially thought their benchmark software was totally broken. A completely fanless MacBook Air was effortlessly outperforming thick, heavy, fan-cooled high-end Intel laptops. Users were suddenly getting 20 hours of battery life on a single charge. From a pure business perspective, Apple saved absolutely billions in profit margins by ditching Intel's premium prices. And most importantly of all, Apple finally secured 100% complete control over their entire hardware, software, and silicon ecosystem. But this wasn't just a big win for Apple. Section 5, changing the industry forever. The M1 completely shattered the illusion that we needed these power-hungry x86 chips. The ripple effects across the entire globe were just massive. Amazon Web Services started building their own ARM-based servers to drastically reduce power consumption in their data centers. Microsoft had to scramble to completely re-architect Windows to support ARM laptops, and Qualcomm slammed the accelerator on their Snapdragon chips. Apple didn't just dump a partner here, they forced the entire legacy computing industry to pivot strictly toward efficiency. And this extreme vertical integration positions Apple perfectly for the next big frontier, AI. Because Apple controls their own manufacturing nodes with TSMC, shrinking down to 3-nanometer and eventually 2-nanometer tech, they've actually been quietly building massive neural engines directly into their silicon for years. This means the future Mac isn't just a portal relying on slow cloud servers, it's a powerful AI system capable of running complex language models and real-time processing locally, privately, right there on your device. Apple redefined the absolute baseline of modern computing, and they left a 15-year partner completely in the dust to do it. So, as the rest of the tech world frantically scrambles to catch up, we want to leave you with this. Who is actually going to dominate this massive, new, ARM-driven AI era of computing?
If you enjoy this video, please like, share, subscribe, and hit the bell to the latest update from my channel. Thank you for watching till the end, and see you in the next video.